Okay, so yesterday we started going through the examples on the weekly worksheet. So you should have that out. We're going to finish the examples and then we're going to jump right into today's notes. So we were on the back side with equivalent fractions. What are equivalent fractions? Rory? Okay, yeah, they have the same value, okay? So if I tell Grayson he gets 1/4 of a pizza, and I tell Audrey she gets 2/8 of a pizza, they actually get the same amount of pizza. It's just Grayson gets one bigger piece, Audrey gets that same amount of pizza just in 2 smaller pieces, okay? If I drew that out, we started on it yesterday, Colby. It should be in your binder. Okay, so if this is Grayson's pizza, there's one pizza split into 4 pieces. Yeah, so he gets one big piece of that pizza. Audrey's pizza, I'm going to draw over the top of Grayson's. Okay, it's the same size pizza, except they just cut it a few more times. Audrey gets 2/8, because if I get 1/4 times 2 times 2, she would get 2/8. So 2 little pieces colored in, but they really get the same amount of pizza. Grayson just got one big piece and Audrey got 2 smaller pieces. But in relation to the whole pizza, they got the same amount of pizza. Okay? So that's what we're doing, is we're creating fractions that represent the same amount of whatever we're referring to. We did 2/3, correct? Yeah. Okay. How do I get equivalent fractions? Noelle, what can I do to 4/5 to get an equivalent fraction? Colby, if you can't find it, grab one on that bottom shelf there. There's some extras. But we did a whole bunch of examples on the front. The bottom tray, you'll have to look through that stack. That's my extra stack. How can I get an equivalent fraction to 4/5?
Times 2.
Where?
Like 4 times 2, that's 8, and then 5 times 2.
Okay, so you have to multiply the numerator and the denominator by the same thing. So I'm going to show times. She wanted to do multiply them both by 2. Times 2 times 2, and she said 4 times 2 is 8. 5 times 2 is 10, so 8/10 is equivalent. Arabella, what else could I do? Nope, we're not dividing. Okay? 4/5 times 3 times 3. And we could divide out to get fractions, but 4/5 is in simplest form. So that's why I said we don't want to divide. So 12/15 works. Who has another one? Mila?
6.
Times 6 times 6. 4/5 times 6 times 6. 24/30. Okay, let's go ahead and mark out that last example. I don't think we need 3 examples of that. Now, all I'm going to say is keep your life easy. Don't multiply by 24 times 24, because then you'd have to go out to the side and do algorithm and you could potentially mess up on your math. So keep it simple when you're doing equivalent fractions. Okay, the next set of examples, we've already gone over these this year, but I want to go over them again because I'm still seeing lots of errors on them. Now, let's talk about why do we do these examples together? Emma? Yeah, so that you have one that you can go back and look at if you get stuck when you're doing it yourself. So, if you've been missing these ones, changing improper to mixed or mixed to improper on your weekly worksheets, when you get to these problems, look at the examples. Okay, who remembers, how do I change 27/5? Waylon?
Take 27 divided by 5.
Yeah, that's really saying 27 divided by 5. I want you guys to go ahead and write this. Leave a spot and then write blank over 5. That's where we're going to write our answer. How do I know that my denominator is going to be a 5? Do you need something? Okay, turn around then. like all the way. Arabella?
Because you're dividing by 5?
You're right, but what do we call that in the problem? We are dividing by 5.
Divisor?
Not the divisor, Callie.
Because your denominator always stays the same.
Yeah, the denominator is staying the same. The denominator is 5 in the improper fraction, so it's going to be 5 in my mixed number. And Waylon was correct, so let's go ahead and write out 27 divided by 5. How many times does 5 go into 27, Colby? 5 times what gives me something close to 27?
5 times 5.
Okay, 5 times 5 gets me really close. So I'm going to put a 5 up here. So 5 goes into 27 5 whole times. And that is 25. So then we subtract and we have a remainder of 2. On the previous weekly worksheets, a lot of people have all of this correct work and then they have the wrong answer because they don't know where the numbers go. How many times did 5 go into 27? 5. 5 whole times. That's where our whole number comes from, is that 5 right there. I'm trying to do different colors so you can see. Where does the 2 go? It becomes my numerator, and this 5 is my denominator, or that 5. It stays the same. Okay, so the remainder becomes the numerator. I'm going to go ahead and write it over here too. Denominator stays the same. Next one, 32/9. I'm going to go ahead and write blank. Leave a blank and write over 9 because I know my denominator is going to stay the same. I think that might help some of the errors I'm seeing. Cam, what math problem do I need to do? Good job. 32 divided by 9. Aubrey, how many times does 9 go into 32?
You could do 9 times 3.
Okay, what is 9 times 3?
8. 27.
27. Good job. Then we subtract and we would get 5. Madison, what do I do with that 5?
You put it as your numerator.
Okay, that becomes my numerator. What's my denominator? Anybody? 9. It stays the same. So 3 5/9. Now, I'm not going to draw this out because it would be lots of them. But 27/5 would mean I would have all these pizzas split into how many equal parts? 5 of them, which isn't an easy one to draw. Oh, that's 6. I did that one right. Okay, but it would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. I only have 25ths so far drawn. 21, 22, 23, 24, 25. There's 25/5. I still need 2 more fifths. 1, 2, 3, 4, 5. Those aren't perfect, but okay. That is showing 27/5. If I said I'm giving you 27/5 pizza, why is that weird?
Because if you say it like that, it just feels like you're just saying.
Yeah, it just sounds weird. That would be like saying I'm giving you 27 slices of pizza that are all 1/5 of a pizza. Okay? I would really just say I'm giving you how many whole pizzas? 5. There's 5 whole pizzas and then 2/5 of another pizza. That's what we're doing. We're changing it from 27/5, 27 slices that are all cut into fifths, into 5 whole pizzas and 2/5 of another one. Okay, so we're just trying to write it in an easier way. I think we're just having a hard time understanding what we're doing there. Okay, let's go down to the last examples. We're going backwards now, changing mixed to improper. How do I change mixed to improper, Caleb? Yeah, we do the little wheel thing. Okay, we start at the bottom and we do multiplication, and then we do addition. We start at the bottom and we wheel around to the numerator of our fraction. So Caleb said we take 6 times 4. What is 6 times 4? 24 plus 1? 25. What about my denominator? Stays the same. We just push it on over. Okay, I want you guys to try 7 2/3. There you go.
Thank you.
Okay, again, when you do finish this worksheet, use the notes. Okay, that's why we take them, is so that you have something to look back on. So if you got 23/3, you're good to go. And you may set that aside and pull out the notes page that says 2.8 notes, estimate products. Okay, what don't you understand? What piece of it?
Where you put the addition.
The addition goes between the whole number and the numerator.
Yeah,
What? On the top. So 6 times 4 is 24, plus 1 is 25. We only put one answer. Because that's saying 4 wholes, so we could write that as 6 over 6, plus 6 over 6, plus 6 over 6, plus 6 over 6. That's 1 whole, 2, 3, 4 wholes, plus 1 more, plus 1/6. When we're adding fractions, the denominator would be the same, but really 6, I have 4 6s, that's where the 4 times 6 comes in. 24 plus 1 more is 25. Okay, so if it doesn't make sense to do the wheel, you can write it out. It's just a lot longer. The wheel is meant to shorten it. Okay, your notes paper should be on your desk. We are estimating today. What does it mean to estimate? What does it mean to estimate? Lily? Emma? Sorry. Okay, and I knew you'd say that. We have to round when we are estimating, but they do not mean the same thing. Okay, they do not mean the same thing, but we have to do them. We have to round in order to estimate. Rory?
like estimate means to find a answer but not the exact answer.
So we're not finding an actual answer. What can we call it? It's not I don't like the word guessing. I like another word before that.
Guessing the best answer.
Okay, it's probably not the best answer because the actual is the best answer. Emma? Okay, it is the simplest to find. I agree with that. It's an educated guess. I don't like just the word guess because guess could be blue, yellow, Tyson. Okay? But estimating is educated guess. I want you to write that up here at the top. Educated guess. Write it above where it says 2.8 notes, because if it tells us to estimated, we are giving an educated guess. Also, we're going to add a little side note. All problems should be mental math. Meaning, if you're having to go out to the side and do algorithm, you're doing it wrong. Okay? Estimating should be easy problems. I'm not saying getting the estimate is always easy, but the math problem involved in an estimate should be mental math. So if you look at it and you cannot do it mentally, you have it incorrect. The vocab word that they want us to know is compatible numbers. What does it mean if two things are compatible, do you think? Dylan?
They go together?
Yeah, they work well together, okay? So we're going to write numbers. Oops, I should have an apostrophe S. Numbers that work well together. In math, what do we usually call those numbers? The ones that work well together. Emma? Fact families. Fact families. So I want you to think fact families. Fact families is a group of compatible numbers. So if I say 4 and 6, what's another number that is compatible with 4 and 6? 2. Okay, depending on which way we're going. What else? What's 4 times 6? 24 is compatible with that. Okay, that's going to be more important when we do division, but we can still think about it with multiplication. But think fact families when you're thinking of compatible numbers. Now, the hardest part about estimating is that you can estimate different ways and be correct. Okay, if Ty estimates the problem one way and gets an answer, Audrey estimates it a different way and gets a different answer, they can both be correct. That's what you will not like, is there's not one right and one wrong answer. There are definitely wrong answers, but there are several right answers. So we're going to be working on finding the best estimate. So when we are working these problems, if you can get by with just changing one of the numbers, try and just change one number. But if you change one number and you're like, nope, not mental math, then you can always change both of them. Okay? So we're going to practice that. The first example we're going to do, and I'm just pulling these from the book, is 92 times 12. So right here where it says estimate by rounding, 92 times 12. If I just changed one number, which one you want to change, Grayson?
92.
Okay, you want to change 92? What would you change 92 to make it easier to work with? 90. Okay, the nearest 10. 90 times 12. Now, for some of you, that's mental math. Why may it not be mental math for some? Waylon? You might not know 9 times 12. So raise your hand if you do know 9 times 12. Okay, Dylan, what is 9 times 12? 108. 108. So what would 90 times 12 be? 1080. We just add the 0. There's the mental math problem that we've been working on in the previous sections. Now, if you're like, I don't know 9 times 12, try and change the other one. Remember, we want to try and just change one. So let's draw a line because we could have done this one different. Let's leave 92 alone. If I leave 92 and I change 12, Colby, what would I have to change that 12 to make it a mental math problem? 92 times what? That's close to 12 could you do mentally?
Can't you keep the same?
Well, do you know 92 times 12 off the top of your head? So what? 10. Yeah, because we know how to multiply things by 10. Colby, what's 92 times 1?
92.
So what's 92 times 10? 920. Both of those estimates are good estimates. You do whichever one works best with your brain. Okay? They're both mental math problems. Now let's talk about high or low estimates. Looking at that first problem, 90 times 12, do you think 1080 is below the actual, Or do you think it's higher than our actual, and why? Who thinks they can answer that and tell me why? Cam? You think it's below the actual? Why do you think that? What do you mean it's not the whole thing? Okay, we did change the problem. How did we change the problem? Yeah, we lowered 92 to 90. So that means our answer will be lower than the actual. Our estimate will be lower than the actual. Put an L out next to that one to show that that one should be a low estimate. Let's look at the second one. What did we change on the second one? Waylon? The 12 to a 10. So did we make the number go up or did we make the number go down? We made it go down, so that also would be a low estimate. I'm going to give you the actual just so we can compare as we're working these. 92 times 12 is 1,104. 1,104 is the actual. Which one was the closest estimate? Waylon?
1,080.
Yeah, 1,080. But are both of them okay? Both of those are okay estimates. Now, sometimes when we change one or the other, we look at the problem and we're like, that's still not a mental math problem for me. And sometimes you have to change both to make them mental math problems. So this is where we would change the 92 to 90 and the 12 to 10. So we're changing both of them to the nearest 10. What is 90 times 10? Grayson? 900. Okay, which one do you think is always going to give us the best answer? Changing both or changing one? Caleb? Changing one will almost always give us the best answer, okay? But all of those are okay estimates, okay? All of those are fine. We're going to go ahead and mark that out because we actually already did it over in where it says round 1. We did it twice. Okay, let's go on down the page. We're going to do some more. There are a few notes here that you may want to underline. It says, when rounding, if you have a single-digit number, leave it as is. Because we know our multiples up to 9, most of us in almost all numbers. So if you have a single-digit number, leave it. Either box that in or underline it. Okay, if you have a single-digit number, leave it alone. And just change the other number, if possible. If you have a 2-digit number, what's it telling us to round it to? The nearest 10. If we have a 3-digit number, we can round it to the nearest 100. Okay, that's just some general rules. So you may want to pay attention to those. Okay, number 9. Round to numbers that are easy to compute mentally. 106 times 52. Let's try and change just one of them. Aubrey, what would you change that to?
I would change 160 to 100.
Okay, 106 to 100 times 52. Is that a mental math problem? Yes. Easton G, what's 100 times 52? So break it down. There you go, 5,200. 52 with 2 zeros behind it. We're going to do this one twice. On your homework, you only have to do it one way. I'm just getting you to think of different ways. What if we left, well, let's change both. We wouldn't want to leave 106 because nobody knows there are multiples of 106 in here. But what is 106 close to that's closer to this number than it is 100? Callie? 110. If we change this to 110 times 50, is that still a mental math problem?
Yes.
Yeah, what's 5 times 11?
55.
55. What? And then how many zeros do I need to add? I have to add 2 zeros. Before I give you the actual, Which one of those do you think is closer? Grayson?
The second one.
Okay, the second one. Raise your hand if you agree with Grayson. Okay, does anybody think the first one? Okay, so we're kind of split on this one. Why do you think the first one, Emma? Okay, because you're just changing one of the numbers. Waylon?
I was gonna answer the bottom one.
Okay, why do you think the bottom one?
Because instead of bringing 100 down, we moved it up, and I think that 106 times 52 is a little bit closer.
Okay, so let's focus on how we change them. And again, I'm just trying to get you to understand estimates. Emma said because we just changed one. And just a second ago, Caleb said he thought when you changed one, that would be the best estimate. And I said most of the time it is. This is actually one where it's not. And here's why. How much did we change 100? We went down 6. On this one, we did change both, but we went up 4 and down 2. So see how we're moving in opposite directions? So sometimes that gets us closer to our actual. Our actual here is 106 times 52. Oops, typed it wrong. 106 times 52. 5,512. Are both of those okay estimates, though?
No.
Yes. They're both perfectly okay. And really, in 5th grade, this is the one they assume you're going to do. But if you know your 11s, which most of you do, this is an even better estimate. But again, they're both 100% correct right now. Okay, number 11, I see a single digit number, so what should I do with it?
Leave it the same.
Leave it alone. Leave it alone. Now, it told us right here, round a 3-digit number to the nearest 100. That is always an okay estimate. Caleb, what's the nearest 100 to 127? 100. So let's write 100 times 8. What's 100 times 8? 800. 100% perfectly okay estimate. Who thinks they could give me a better estimate? Drake?
130.
Okay, 130 times 8 is a good place to go because that's rounding it to the nearest 8. But why might we get stuck here? Emma?
Because a lot of us don't know it.
Yeah, a lot of us don't know our multiples of 13, okay? If you know 13 times 8 without having to work it out to the side, you can round it to 130. And again, I want you to process that. Think about it. Okay, 130 is closest, but when you write it down, you're like, nope, not mental math. If you write it down and you're like, nope, not mental math, just mark it out. But what's a number between 100 and 130 that we can do mentally? Brennan?
150.
150 is getting too high. We're still trying to stay close to 127. 110, or what's even? Could we do 120 times 8?
Yes.
Because now we're just doing our multiples of 12. What's 12 times 8? 96. We add our 0. Again, is 100 times 8 acceptable? Yes, I'm just trying to get you guys to push yourself. Okay, if you can do 12 times 8, do 120 times 8. The actual would be 127 times 8. 1,016. 1,016. Rory?
I did the 130 one, but it was 1,004. Yeah, it was 14.
Yeah. Yep. That's why I said if you can do 13, but again, I don't want you to go out the side and do algorithm.
I didn't.
Okay. So we're going to mark off a different way because we just did it 4 different ways. Okay, that's what I'm trying to show you here is there's lots of different ways that are all what?
Right.
Correct. Okay, what you do and what your neighbor does may not be the same thing. Flip your paper to the back. We're just going to do one word problem out of the book. We're going to spend all day tomorrow on word problems, so we're just going to do one today. I'm just going to read this one to you, and then we're going to just jot down the important information. Number 15 on page 128 says, the table shows the number of pounds of apples that were harvested each day. What does harvested mean? Callie? Grown. Picked. Estimate how many pounds of apples were harvested all together by rounding and show how you estimated. So we're going to draw a T-chart because that's how it gives us the information in the book on the chart. So in box 15, just draw a little chart. Doesn't have to be anything fancy. On one side it has the day, and on one side it has the pounds. And then we did it for 5 days, so I'm going to go ahead and just fill this in a little bit.
In the whole box or to the side?
To the side, because we're still going to do some math over on the other side. Now, in the actual chart, it tells me on day 1, they harvested 514 pounds of apples. What is a much easier number to work with than 514? Emma? 510, or what's even easier? 500. Keep it simple. So we're going to write 500 pounds. That's our estimate, or that's our rounded answer, our rounded number. On day 2, they picked 487 pounds of apples. Caleb?
490?
Do you know your multiples of 49? No. So what would we round that to? 487 we would round to? 500. Day 3, they harvested 349. 349. Madison? 300. Day 4, 420. Callie? 400. And day 5, they harvested 392. Zach, what would we round that one to? 392. 400. Okay, now that I've rounded all my numbers, I'm going to reread the problem. It said, estimate how many pounds of apples were harvested all together. What does that tell me to do? What math do I need to do? Brennan? I need to add them together. So I'm going to come out here to the side. Lots of rows of zeros. Let's add that column together. What's 5 plus 5? 10 plus 3?
13.
Plus 4?
17.
Plus 4. 2, 1. So my answer would be about 2,100 pounds of apples. Okay, I'm going to pause the video and pass out your homework, but I still want to talk about it. I'm going to go ahead and clear this. You might have to copy from a neighbor for a sec. Okay, on the worksheet, flip it to the side that's up on the board now. This is the front side. On this side, it says estimate the products by rounding a factor or both factors to the nearest 10. Round both the factors. Kind of confusing directions. If you can, change one. If you change one and it's still not mental math, change them both to make it mental math. Let's do number 1 together. Who thinks they know what I can change 5 times 69 to make it mental math? Aubrey?
5 times 70.
5 times 70, yep. So let's write 5 times 70. So you are showing me your new problem, your rounded problem, and then you're giving me your estimate. Easton T, what's 5 times 70? 350, good job. So on the front side, that's what all your problems will look like. You'll have your rounded problem and your estimate. Flip it to the back. Give me just a second to get there. On the back, it is all word problems. I'm going to have you make a note at the top. do not solve.
Just write down the.
I'm going to tell you, you do not solve. You are going to write the actual problem and the rounded problem. Okay? So you do not solve. You are going to write the actual problem and the rounded problem. We're going to do number 1 together so you know exactly what I mean. Notice there's also not a lot of room to work here. So it says a ketchup company purchased 78 shipments of tomatoes. There were 23 tomatoes in each shipment. So we got 78 shipments, 23 tomatoes, 78 different times. What is my math problem here? Callie?
78 times 23.
78 times 23 is my actual math problem. And then just draw a squiggly to show we're going to change that. What would my rounded problem be? My mental math problem. Emma? E? Well, let's look at this one. If I just changed one, do we know our multiples of 23 or our multiples of 78? No. So this is one we would have to change both to the nearest 10. Where would that get us? 80 times 20. And that's all you have to do tonight. You do not have to finish them and write an answer sentence. Does that make sense? So the front 10, you're estimating, which means round the problem, do your mental math. On the back, you're writing the actual problem and the rounded problem, and that's it. Okay? Go ahead and get started on your homework. You don't have a ton of time, but you can probably get several problems done. And weekly worksheet is due when? Friday.